Welcome to our video presentation on reversing the order of words in a sentence while preserving punctuation marks.
We will be demonstrating a function that takes in sentence as a string and return the sentence with the words in reverse order while keeping the punctuation marks in the original position.
The pseudocode for the function is as follows. First, create a vector to hold the words and punctuation. Second, create a string to hold the current word. Third, iterate through each character in the sentence. If the character is a letter or a number, add it to the current word. If the character is not a letter or a number, add the current word to the vector and add the punctuation mark to the vector as its own string.
After all words and punctuation have been added to the vector, then we create a new string to hold the reverse sentence. Next, we iterate through the vector in reverse order and add each word or punctuation mark to the reverse sentence. Finally, we return the reverse sentence.
Let's take a look at the C++ implementation of the function.
As you can see, the function uses the STL library vector and string, and the helper function is unknown to check if a character is an alphanumeric. It also uses a range-based for loop to iterate through the sentence.
Now let's take a look at an example of the function in action. Finally, the function returns the reversed sentence as the output. The pseudocode, algorithm, flowchart, and source code provided in the previous answer give more detailed explanations and examples of how this function works. Thank you for watching our video presentation. We hope you have a better understanding of how to reverse the order of words in a sentence while preserving punctuation marks.
Hello and welcome to our video presentation on how to develop and use a program to print all prime numbers in a given string.
In this video, we will be walking you through the process of developing this program from writing the code to testing it out.
The first step in developing this program is to define a helper function called is_prime, which takes an integer as input.
Inside the is_prime function, we will check for edge cases where the input number is less than or equal to 1, in which case we will return false.
If the input number is less than or equal to 3, we will return true.
We will also check if the input number is divisible by 2 or 3, and if so, we will return false.
Next, we will iterate from 5 to the square root of the input number and check if the input number is divisible by the current number or the current number plus 2.
If the input is divisible by any of the numbers in the previous step, we will return false.
Otherwise, we will return true.
Now that we have our helper function, we can define our main function called print_primes, which takes a string as input.
Inside the print_primes function, we will iterate through each character in the input string.
For each character, we will check if it is a digit, and if so, convert it to an integer.
We will then check if the integer is prime using the is_prime function.
If the integer is prime, we will print it out.
After the end of the loop, we will print a new line. The program will iterate through each character in the string and find that the only digit in the string is the number 1.
Since 1 is not a prime number, the program will not print anything.
And that's it! With these simple steps, we can easily develop and use a program to print all prime numbers in a given string. Thank you for watching, and we hope you found this video presentation helpful.